The first unit is the kinematics unit. Kinematics is the description of motion. To describe motion, we use these terms: the position, the changing position, distance traveled, and we have velocity, speed, and acceleration. Now, position is a vector because if I have an x-axis being 2 meters to the right of an origin is not the same as the 2 meters to the left of the origin. So position is a vector. Delta x is the displacement, and the delta x by definition the change in position, that will be the final minus the initial position. Because position is a vector, the displacement, the change in position, is also a vector. The distance traveled, on the other hand, is just the length of a path. So distance traveled is a scalar. So if an object travels along a straight line, the changing position, the position starts from here, the position ends there. The changing position has a length that is the same as the length of the path. So in this case, the displacement and the distance traveled would have the same numbers. The only thing is, if the displacement goes in the negative x direction, then the displacement, if the displacement is negative 5 meters, the distance traveled will only be 5 meters without the sign, because the sign for a vector means direction. But if an object goes zigzag or circle around, then the displacement, the changing position, the position changes from here to here, the displacement, the changing position will not be the same as the distance traveled. Same thing here. If the object circles around, the changing position will be from here to there, but the distance traveled would be the length of this path. So if an object zigzags or circles around, the displacement and the distance traveled would not have the same numbers. For velocity, we have average velocity. When we put a bar on the top, means average. The average velocity by definition is the changing position divided by the time. And we have speed. The average speed is the distance traveled divided by the time. So velocity is a vector because it comes from a vector. Speed is a scalar because it comes from the scalar. So if an object goes zigzag or circle around, then the displacement and distance traveled will not have the same numbers. That means the average velocity and the average speed will not have the same numbers either. If we write the v without the bar on the top, this means it's an instantaneous value. The instantaneous velocity is also an average. But this will be an average taken under the limit when the time is very short, that it approaches to 0. Same thing here. The instantaneous speed is an average speed, the distance traveled divided by the time, but this is an average taken over a very short amount of time. Acceleration. By definition, average acceleration is the delta v over delta t. It is the rate at which the velocity changes. It is also a vector because it comes from velocity, the vector. And then, of course, we have instantaneous acceleration. It is an average acceleration, but it is an average taken over a very short amount of time again. Now, because of this definition, we can see that the delta x, the displacement, would equal to average velocity times time. In terms of graph, if we have a velocity versus time graph, because we're multiplying, this would be the area of the graph, because this is the height times the base. The height, The height is the velocity, so the vertical axis must be the velocity. The base is the delta t, so the base is delta t. That means the horizontal axis must be the t. So this, when you are multiplying, it is the area of a graph. Velocity is delta x over delta t. So this is a part of the position versus time graph. If we are dividing, that means it is the slope of the graph, because the slope is the rise over run. If that's the rise, this is the run. The rise is delta x. That means the vertical axis must be x. Over delta t, that's the run. If the run is delta t, the horizontal axis has to be the time. Again, for this one, this one doesn't have it. For acceleration will be which part of the velocity versus time graph? It's that because this is rise over run, so this is the slope of the graph, and that's velocity versus time graph. And of course, from this definition, we can see that a delta v is average acceleration times time. So if delta v is average acceleration times time, because we're multiplying, it must be which part of the graph? It must be the height times the base. So it's the area of the graph, and then it will be the area of, this is the height, so it is a. This is the base, so the horizontal axis is the t. For example, I can give you a position versus time graph that looks like this. And I can ask you to find the displacement between 3 and 7 seconds, average velocity between 3 and 7 seconds, and the instantaneous velocity at the 4 seconds. We're just going to talk about the methods here. To find the displacement, if we have a position versus time graph, that means we know the initial position and the final position, because we can just read them off the graph. So we can say delta x is the final minus the initial position. And then to find the average velocity, for a graph problem, if we're looking for the average value, we'll go by the definition. What is the definition for average velocity? It is delta x over delta t. So we can just do the final minus initial to find the delta x, and then divide it by the time. Then of course this will be 7 minus 3 seconds. The final time minus the initial time. The time duration is 4 seconds. So that answer goes here, and then we can find the average velocity. If we want the instantaneous velocity, then the instantaneous velocity for a position versus time graph is going to be the slope. Since this segment is straight, we can use any part of the segment. We just have to do the rise over run. Of course, in this case, the rise is negative number divided by the run, a positive number. Now for the same shape graph, if now I label it as velocity versus time graph, see what we can do to find these ones. Delta x from a velocity versus time graph, because delta x is the average velocity times time. If we're multiplying, this is the area of the graph. And when we talk about area of a graph, we would want, in this case, of course, only the graph area between 3 seconds and 7 seconds. And whenever we're looking for the area of the graph, it's always the area between the graph and the zero line. So it is the area up here and down there. Above the zero line, we get positive displacement. Below the zero line, we get negative displacement. So the net displacement would be this positive number plus that negative number. To find the average velocity, again, for a graph problem, if we want the average value, we go by definition. So the average velocity would be the delta x over delta t. That's the definition. So of course, we have the area earlier, and then just divide that by the delta t. For average acceleration, same thing. We go by definition, And what's the definition of average acceleration? It is the delta v over delta t. So how do we find delta v? Let's see, the graph gives us the velocity. So we will be able to find the initial velocity and the final velocity, and then use the final value minus the initial value to get the change in velocity. And then divide by the time, we get the average acceleration. If we want the velocity at a certain moment, because this is a velocity graph, we just have to read off the graph. The velocity at 4 seconds, now it's 0. So just read off the graph. If we want the instantaneous acceleration at 4 seconds, now this is acceleration, average acceleration is delta v over delta t. Since we're dividing, this instantaneous value is going to be the slope, the rise over run. So we just have to use a segment that is straight and then make a triangle. Then the rise over run will give us the slope. If we have a position versus time graph, okay, doesn't matter where you start with, as long as you have a straight line, or either slanted or horizontal or slanted down, as long as the position versus time graph is a straight line, that means the velocity, which is the slope of this graph, is a constant. If the velocity is a constant, that means the acceleration is 0. And if you have a position versus time graph that is a curve, if it's a curve, of course, the acceleration would not be 0. But if you have a position versus time graph that is any part of an upward curve, that means the acceleration is positive. If your position versus time graph is any part of a downward curve, that means the acceleration is negative. Because if we have an upward curve, that means the velocity, the slope of this graph starts out negative and then gets less and less negative and then becomes 0, and then the slope gets positive, more and more positive. So this trend gives us a positive acceleration because the velocity is changing in the positive direction. If the position versus time graph is a downward curve, that means the slope starts out positive and then it gets less and less negative until the slope is 0, and then it gets more and more negative. So the change in velocity is in the negative direction. That's why the acceleration is negative. So if I have a position versus time graph that is like this, then we'll say the velocity, which is the slope, is positive. But this is a part of a downward curve. Therefore, its acceleration would be negative. Then we study the two different kinds of special kinds of motion. One is a constant velocity motion. For constant velocity motion, the only equation we need is the displacement is velocity times time. And then we have the constant acceleration motion. In that case, we have 4 kinematics equations. See if you remember those equations. It's the final velocity equals to the initial velocity plus at. This is the final velocity equals to the velocity you have at the beginning plus the rate at which the velocity changes times time. When you multiply the rate of change by the time, we get the change in velocity. So what we start with plus the change gives us what we have at the end. And then the displacement is velocity times time, the initial velocity times time, plus 1/2 at squared. And then we have v squared equals to vo squared plus 2a times the delta x. And then the fourth one was delta x equals to average velocity times time. And the 4 constant acceleration motion only. The average velocity is initial plus final divided by 2. So the average velocity is the average of the initial and final velocities. And this is not always true. This is just for constant acceleration motions. But this one is always true because this one is from the definition of average velocity. The average velocity is always delta x over t. If you count the number of variables we have in here, we would have 1, 2, 3, 4, and the delta x. There are altogether 5 items. And in each equation, there are 1, 2, 3, 4. 4 things involved: delta x, VO, t, and a. Which means in order for us to be able to solve a constant acceleration motion problem, we need to know at least 3 things. If we know 3 things, we find one equation and plug in the 3 things, we'll be able to find the 4th one. And then we get another equation, we plug in what we know, and then we'll be able to find the 5th quantity. So for constant acceleration motion, if we can just list 3 things we know, we'll be able to solve that problem. Okay, another thing is acceleration, velocity, or final velocity, initial or final velocity, and displacement, they are all vectors. So the signs are important. The signs tell us about the direction. So if an object starts with an initial velocity that is positive, and this object slows down, which means the acceleration is in the opposite direction, then we'll have to make the acceleration a negative number. Then we talked about the free fall. If an object is in free fall, which means we can ignore the air resistance, then the acceleration is constant. It is that gravitational acceleration g, and it is a downward acceleration. And for falling object, in the vertical direction, we usually choose up as positive, and we use y for that. We don't have to. If you want to, you can choose down as positive. But right now, I'm going to choose up as positive. If I choose up as positive, then that means this downward acceleration will have to be negative. Okay, and the g is 9.8 meters per second squared. And we usually just round it to -10. And because it's a constant acceleration motion, that means that we can use those 4 kinematics equations for constant acceleration motion. Now, if we have an object that is released from rest, that means the initial velocity is 0. We can, of course, also release an object from a moving object. For example, we can release an object from a helicopter. That means if the helicopter is moving, the initial velocity will not be 0. If the helicopter is moving downward at 3 meters per second when the object is released, then the initial velocity would be that downward 3 meters per second. If I use upwards positive, then this will be -3 for the initial velocity. If the helicopter is moving at upward 3 meters per second at the time of the release, then the initial velocity of the object would be upward 3, positive 3. We can also have an object starting out that's thrown either upward or downward. If we throw something upward, that means the initial velocity is positive. And then, of course, the acceleration is still that downward gravitational acceleration, so the acceleration will still be negative number. If an object starts out getting thrown downward, then the initial velocity would be negative. Acceleration is also negative. Of course, if we throw something upward, it can go up and then come back down. And what's special about the velocity at that maximum height? The velocity is 0 at the maximum height because that's a turning point. If the object goes up and then lands lower, That means the delta y, the changing position, the position starts there, the position ends there. The change in position is a downward vector, so the delta y would be a negative number. If the object thrown lands higher, that means the delta y would be a positive number. Because the object starts here, ends there, the displacement is an upward vector. That's why it's positive, if this is the coordinate system we choose. Now you may wish to take a look at the practice problems and find a few problems to do to help with the review. Or, of course, you can also use kinematics unit videos for review practice.